Hello and welcome back to Math with Patrick. Today is July 19th and we're solving problem number 200 from the Daily Epsilon calendar. We need to figure out why 19 is the smallest prime number that is the sum of three different primes. So how about let's search some of our small numbers for primes and then see what happens when we add them up. So the smallest prime is 2. And it's the only even prime, so all other even numbers won't be prime. Then we're going to have 3. 4 is not prime, but 5 is. 6 isn't. 7 is. 8, 9, and 10 are not. And then we're going to have 11. Maybe we'll need 13 for this problem, but I think that's as far as I really need to go. I like to think of primes as like multiplicative building blocks. So like we could use 2 and 3 to build a 6. We could use like 5 and 7 to make 35. And then if you have some number, say like 44, we can always break it apart into other numbers. Some will be prime, like 11, and others you can break up even further into other numbers. So that's like my general, like kind of by feeling definition of primes, that there are these like building blocks, multiplicatively anyways, for our natural numbers. Now, something a little silly about them, or about this problem rather, is that we're adding these primes instead of multiplying them. So it's almost like we're using them a little bit outside of their typical use. Let's see what happens when we try adding some prime numbers. So like if we add these three, the smallest three, we're going to get the smallest number. That's the sum of three different primes. 3 and 5 make 8. I was already getting ahead of myself there. And then 2 and 8 make a 10. So 10 isn't prime, and moreover, it's actually even. And I think if we try using the 2 with any other prime numbers, since all the other prime numbers are odd, like the 5 and the 7 are going to make a 12, add on the 2, we get 14. We're always going to get an even number out of this, and so we can't use 2 in our sum. So the next one to check is 3, 5, and 7. These are the next three smallest primes. We can't use 2, again, because if we did, we'd get an even sum. Here we have 3 plus 7 plus 5 is 15. This is not prime. 3 times 5 is 15. Maybe another way to kind of see that is we have these kind of consecutive numbers. 3 plus 2 is 5, plus another 2 is 7. And I'm pretty sure every time you add 3 consecutive numbers, even if like you're not adding by like plus 1, like maybe you're even adding like plus 5 and then plus 5, or I think you could add pretty much any number here and come up with some kind of number sequence. And anytime you add those 3, you're always going to get 3 times the middle one. So we can't pick these 3 numbers because then we get another composite number or a non-prime. So I ruled out 2 because, well, we couldn't use it. But ruling out this sum doesn't mean that I'm ruling out 3, but rather I should replace one of these 3 numbers with a different one. And I think the next logical thing for me to try is to replace the 7 with an 11 and see what happens. So with 3 and 5, we get 8, plus 11, we do get 19. So here is our answer. But I just want to make sure that there isn't like a smaller number, right? So we found this 19, but maybe there's actually a smaller way than doing 3, 5, and 11. But there isn't, right? Because 3 is the smallest number, 5 is the next smallest number. Yeah, okay, never mind. And so since adding 7 didn't work, the next thing we could have done was look over at the next biggest prime number. So this indeed is the smallest option for us to add 3 numbers together, add 3 primes together, and get another prime. So never mind. That's it. There's a 19, and I'm very convinced that that's the smallest prime. That's the sum of 3 others. So we are all done for today. Thanks for coming along for problem number 200, and I'll see you tomorrow for problem number 201. Bye.